Okay. All right, so we're going to be looking at module number 1, which is going to comprise 2 chapters. The first chapter is going to be chapter 1, which we're going to get a good start on tonight. And the second chapter is going to be 4. The first chapter that we're going to be starting on is going to be dedicated to learning how to create standard kinematic diagrams, okay? And just getting to know the terminology and just like getting ourselves, familiar with the process. So we're going to start by looking at learning plan for module 1A, which is part 1. And this again pertains to the first chapter in our book, chapter 1. Now, as I had stated in our course overview, you are only responsible for the chapters or the sections that I outline in our PowerPoint and or go over in class. Additionally, we are going to be going over examples as part of your practice problems. So if we take a peek at module 1 practice problems, you're going to notice there's a list here of the examples we're going to be going through. Again, we're doing 1.1 through 1.4, but then we're skipping to 1.9. So we're not doing all the examples in the chapter. Make sure that you look at the specific assignments, practice problem or assignment, to know exactly which ones we're going to be focusing on. But as stated on the top here, follow along with the lecture and complete the following practice problems demonstrated by the instructor. So I will be going over all of these. Again, practice problems are exactly that, getting practice. So, so let me go back to our module and I'm going to pull up our PowerPoint presentation to get started. So we'll do a little bit of background information here first, and then we'll get into the example problems. So chapter 1, Introduction to Mechanisms and Kinematics. So first of all, the objectives of this chapter or this section are going to be to get started in explaining the need for kinematic analysis in mechanisms, define some basic concepts that comprise a mechanism, learn how to draw kind of the standard kinematic diagram using a complex machine, compute the number of degrees of freedom, or what we call the mobility, and then also being able to actively identify 4-bar mechanism and a slider crank mechanism, because those are going to be very popular and they're going to come up repeatedly as we start going into other chapters and modules. So first of all, kinematics. The definition of kinematics is it's the study of motion without regard to forces that cause it. That's very important distinction. In a lot of other classes, we are interested in mechanical design. What are the forces that are acting? Because that's going to then feed into what are the materials that we're going to use. And usually we want to jump there. But kinematics pauses and it says, no, we're just going to worry about right now what's happening with the motion. Okay, how much space do we need? I like to say that it's the layout work that we need to do before we start figuring out the other stuff. Okay, it literally is the first step in the design process. Okay. So when we look at mechanisms in a machine is going to be devices that are used to alter, transmit, and direct forces to accomplish a specific objective. Okay. So a chainsaw, for instance, it's a familiar type of a machine, and it's going to direct the forces to the chain with the objective of cutting wood. Okay. Now a mechanism is going to be a mechanical portion of that machine, a smaller portion of it that's going to function in transferring the motion and the forces. But in kinematics, we're concerned just about the first part of that statement, the motion only. Okay. The mechanism can be considered rigid parts that are arranged and connected so that they can produce the desired motion for that machine. So for instance, on a chainsaw, the mechanism that takes the power from the small engine, okay, and delivers it to the cutting edge of that saw. That would be the kinematic part of the design of that mechanism. Okay. Now, kinematic analysis is going to involve the following. Where are we at? What is the position of, one of the elements in the mechanism? So as we look on the right-hand side here, we have a mechanism and it is going to go around in a circle. This is called what we call the driving link. It is going to go around in a circle and it is connected through a connecting rod to a slider that goes back and forth. So what we would want to do in this kinematic analysis is identify or define how fast this is rotating and in what direction. And based on the position that we are in that rotation, then where would this slider be at any given point? Okay, that's a typical kinematic analysis. So position, displacement, rotation, speed, velocity, acceleration. We're going to be hitting all of these during this term. Okay. Again, it's the first step. Notice there's one thing that's not here that a lot of times in mechanical design we're worried about. What is that one thing that's not here? Starts with an F. There's no forces. We're not worried about forces yet. This is just, I like to say, the layout. It's how much space, how fast are we going? What is the displacement? How much room do we need for this to occur? Example in figure 1-2, which is in your book, it's a platform very similar to this. A kinematic analysis is going to answer the following questions. For instance, what is the significance of the length of the legs of this platform? So you'll notice that we have a platform that is on the top here. We have legs that cross, and as we reposition these legs along the base or the bottom of the top platform, the height of this is going to change. So what is the significance of the length of those legs? Depending on how long they are is going to depend on how high or low the top portion of our platform is going to be. Where is that distance? We might want to ask, is it necessary to support the legs to cross and be connected at mid-span? Could we connect them someplace else? Okay, that's a kinematic analysis. And then how far must the cylinder extend to raise the platform 8 inches? Now, in this case, you're going to notice we don't see a cylinder in there, but if we look under the camera here, there is a cylinder in the case of the illustration that we have in the book. So the one that came with the PowerPoint slides for some reason didn't have it. So this is a cylinder that's in here. So if it's a hydraulic or a pneumatic cylinder, we would want to know how far do we need to extend that in order to get this to the appropriate height. That's kinematic analysis. We're not worried about how much pressure we need. We're not worried about how much force is on there. We're not worried about how thick those are going to be. We just want to know about position, displacement, that type of thing. Okay, that's what kinematic analysis is all about. So some terminology that we're going to come across. First of all, a linkage is going to be a mechanism where all the parts are connected in a closed chain. A frame member is going to be the one link that does not move and remain stationary for that particular mechanism. Links are going to be the individual parts of a mechanism. A joint is going to be a movable connection between links that allows relative motion. So if we look at figure 1-3 on page 3, there are 2 different types of joints. There's a pin joint and a sliding joint. So over here, in this illustration right here, the joint on the left is called a pin joint. So we have a pin going through, it's connecting 2 different members or links, and they can rotate relative to one another about that center of rotation on that pin. Okay, a very typical, called a primary type of a joint. The other type of primary joint is called a slider. A slider is going to allow motion that is going to be in a linear fashion. In this case, we're seeing it as horizontal, but it can also be vertical. Okay, so in this case, we have rotational about a pin. In this case, we have sliding in a horizontal direction. Now there's 2 different types of links as well. There's a simple link and there's a complex link. A simple link is going to be a rigid body that contains 2 joints, only 2 joints. A complex link is going to have more than 2 joints. So if we look on that same page, but lower, figure 1-6 at the bottom, see this at the bottom, you're going to notice that this is a simple link. This is a rigid link. In this case, it's a straight link. And on either end, there's a pin joint and a pin joint. So we have 2 joints on one link, a simple link. A complex link is where we have 1, 2, 3 joints, more than 2 on one complex link. This is considered a complex link. Anything that has more than two joints on it, that it connects to more than two other places. Okay. Now, a point of interest is going to be an interest along a link where the motion is of special interest, but there might not be at a pin connection. So it's going to be something that we're going to be interested in, maybe some displacement, velocity, acceleration calculations for it. So for instance, we're going to be looking at example 1.1. And if we look at this mechanism, and we'll be looking at it in detail in just a little bit, the handle out here does not connect to another member. So it is not a joint, but the significance of the end of that handle might be important because we would want to know how far are we going to move that if we're going to manually do it? And does it make sense, for whatever, operation that we have? If we look at a hand tool, for instance, we would be interested in, when I have this open, let me zoom out a little bit, how wide this is, so that is it appropriate for a human hand? If it's super wide and I can't get a single hand around it, well, then it's really not a hand tool. It's not going to work very well for us. So even though out here we don't have any joints that are going to connect, we would be interested in how far they would be apart so that it would make sense for them to, easily be actuated using a human hand. So special interest points can come in a lot of different ways, and they're going to be special interest based on, what the design is that you're looking at. A lot of times we might be interested as well in making sure that we don't interfere with something. So we want to make sure that we account for it. So kinematic diagrams. A kinematic diagram is going to be a stripped down or a simplified version of a machine, okay, or a mechanism. The purpose of a kinematic diagram is to represent the variables that affect the primary function of the movement. So down here, you're going to notice that we have what we call a toggle clamp, okay? The toggle clamp has 1, 2, 3, 4 links in it, okay? And using standard kinematic analysis or kinematic symbols over on the right-hand side, this is what our kinematic diagram would look like. Doesn't look anything like a toggle clamp that we see over on the left-hand side, but it would give us the appropriate range of motion of each one of the links, okay? Now, you're going to notice that we have some standard, we have some triangles here that represent the different links, but the points of interest you're going to see are labeled as a Y and an X. And that's going to be if you would, the furthest point out here where we would actually do the clamping, and the furthest point on this side on the handle for where we would manually actuate it to make sure we know where it's at in space at any given time. If we look at table 1.1, which starts on page 5, we can see some of the standard symbols that we're going to be, coming across for diagrams. So I'm going to go underneath, and the table that we're going to look at is right here, table 1.1. So the typical form of a simple link is going to be just a bar that has 2 connections on either end. To show this in kinematic form, in a diagram form, we're just going to represent this with a single line connected by 2 endpoints that are filled in. These 2 filled in endpoints mean that those are available to connect with another link. They're a joint, okay? The next one that we have here is a simple link with a point of interest. So in this case, we have this connecting rod, and it's got, I'm going to call it a dog leg in it. So the 2 points where we have the ability to have joints are on the ends, but we might be interested in making sure that we understand and know where that bend is so that it doesn't interfere with something in the assembly. Okay. If it's not of interest, it doesn't mean that it has to be. And you're just like, I'm not really concerned about that little bend. You could represent this as a single line as well. Okay. You as the designer will really know a little bit more about what's important for that, that diagram. The next one is a complex link. That's where we have a single link, but it has more than 2 joints. Okay. And we see those joints as dots. Notice that if there is not a joint and it's a special interest point, we do not put a dot at the end, only when we're connecting to something else, like a pin is there that's going to give us relative motion. This is a pin joint, right, where we have 2 links that are coming together. Okay, notice we don't show the overlap of material. All we show is where the connection is, and then a simple line representing each one of those links as it comes together. Okay, no details, stripped down, simplified. That's what we're interested in for kinematic diagrams. The last one that we're going to come upon on a regular basis is going to be a sliding joint. One version of a sliding joint can be a linear bearing, for instance, where we've got the carriage that is going to go along the rail here. This is confined to linear motion only, in this case, horizontal. So we are going to show that as a rectangle, and a slider can come in a lot of forms. We're going to find that we're going to be seeing a slider in the form of a cutter, okay? But we're going to represent it as a simple rectangle. And then the line underneath this one shows that it's going in a horizontal direction, but we can orient this 90 degrees so that it can be vertical or even at an angle, okay? So it really just depends on the type and the orientation of where it's being constrained. The next two are called higher order joints. We're really not going to talk about those so much in Module 1 here. We are going to be hitting cams and gears towards the end of the course, about 3/4 of the way through the course. So we'll address those at that time, but they're considered what we call higher order joints, and they're shown in the way that we see here. So let's catch up in our PowerPoint presentation. So we went over table 1.1. So now we're ready to look at example 1.1. Now, example 1.1, let's look at what the problem statement says here. Is example 1.1 says, in the figures we see down here below, it shows the shear that is used to cut and trim electronic circuit board laminates. Draw the kinematic diagram. Now, what I want you to do for this one is, this is the first practice problem that you're going to be submitting. For this one, we're just going to sketch it, okay? So I just want you to go through the process, make sure you kind of understand, and we'll kind of look at this together. So, so if you would, just pull out a piece of paper where you can sketch this form. It doesn't have to be real big, okay? I'm gonna probably use the top fourth of my piece of paper here to draw this. So big enough that I can add some labels, but not super tiny, okay? So what we have here, and oopsie. I don't know why that comes up. All right. So I'm going to zoom in here for a little bit. We're going to look at this mechanism. So what we have here is we have a manually operated shear. And what happens is, this is the handle that is going to rotate around this point right there. Okay. This point right here is attached to a stationary element, which we're going to call the frame. The frame is always going to be the part of a kinematic mechanism that does not move. Okay. Sometimes it's obvious and we can see the part is not moving. It might be bolted down like we see in this case, actually on either side here. But sometimes it's just, we assign it as not moving. In the case of like a hand tool, for instance, this doesn't have any points that are sitting down, but we could assign one of the handles to stay stationary and act as our frame. And that's what we're going to do when we actually look at this one. But for right now, our frame is going to be anything that's not going to move. So our handle is going to be pivoting around a point that isn't going to move, which is going to be our frame. So then we have our handle. So we have our frame here. We've got our handle. We've got then a connecting rod that then goes to the blade that is constrained vertically, sliding up and down. So this handle is going to have rotary motion, and our output, which is going to be our blade going up and down, is going to have linear motion. Now, the process that we go through as far as creating our kinematic diagram, we first want to identify what is our frame member, what is stationary, and what is moving. So if we look here, okay, we already identified that this point, and we can see that this whole little, frame member here is the frame. It's bolted down. It's going to be stationary. So this connection right here to our handle is going to be considered a stationary pin, if you would, a stationary part. That's going to be our frame. Additionally, where it's constrained vertically here, this is not going to move either. That is also part of the frame. They're two separate pieces, but they're considered one link. Yes.
So basically the frame is whatever we would consider fixed if we were designing this in 3D.
Correct. So Christian just brought up a good point. If we were designing this in 3D, it's anything that is fixed. Yes, yes. It's not going to be moving. Okay. Now the next type, so we've got our stationary point here, which is going to be our frame. And then connected to that, we have a link. Our link is our handle. Now, in this case, as we look at this, can you tell me if our handle is a simple or a complex link? Why do you say it's a simple? Simple is correct. Go ahead, Christian.
There's only two.
There are two joints on it. Now it extends back up here and you'll notice that I have an X. What would that be considered out here? Do you remember what that's called? A point of interest, exactly. This is not a joint out here. It's just that. It's a point of interest. It's something I'm interested in knowing. What is the rotation or the travel that's going to create? So that's going to be a simple link for us. The next link that we have connects our handle to our blade, and our blade is going to go vertically. What type of a link is connecting here? It's another simple, right? And again, we've got 1, 2 connections. And then lastly, we've got the blade. The blade is going to be moving linear up and down. What type of a link is that? It's a slider, right? It's a slider. So if we kind of look back at table 1.1, we can identify what each one of these is going to look like. So our frame, actually, I don't think we show a frame on here. I'm going to be telling you what a frame looks like. So the frame I'm going to introduce in a little bit. But as we look at our simple links that have a point of interest, for instance, we are going to, we are going to be representing it in some sort of a way like this. Now, it might not look like a triangle as we see it here, but it's going to have a point of interest on it, and it's going to have 2 places where we're going to have available joints. That simple link that it was just straight without a point of interest, that's going to be another joint that we have. And then we also said that we have a slider, okay? Now, if we peek ahead to page 7, where they drew their kinematic diagram, this is what we're going to sketch and make sure that we understand all of the elements that are here, okay? So first of all, we're going to start at the frame. A frame is always going to have a symbol that has a half circle on the top, a little bit down, and then it's going to be attached. This would be like a hatched portion. So over on the right, I kind of sketched that out, okay? When we look at a simple link is simply going to be a line connecting where the joints connect. So this would be, if we weren't interested in that point of interest X at the end of the handle, this handle could just have the distance between A and B here, okay? And then here's where it's actually connecting to 2 different links. Notice there is not a dot out at X because there's no connection. There's no joint out there. That's just a point in space that we're interested in knowing about. Then the connecting rod that goes in between the handle and the slider, or that cutter going down. And then you're going to notice that we have the cutter being represented. Now, in this case, you're going to notice that we just show this as a simple rectangle, representing it as a slider because it's constrained vertically. If you wanted a point of interest on that slider, you could add the portion of the blade that actually sticks out, because you might be interested in where that is at any given point in space, okay? In some cases, your kinematic diagram might agree with the book, and in some cases it might not. But you as the designer might have some more information of what you're interested in, so that's okay. So let's sketch out our kinematic diagram for this. So we're going to use that final diagram kind of as a gauge, but we're going to sketch this out so we kind of have a better understanding of how they got what they did. So the first thing we're going to do is start with our frame member, and our frame member is going to be right there at that point where the handle is going to connect. So I am going to draw kind of that half circle going down. This kind of anchors it with the hatching, and then we're going to have that joint right in the middle there. Okay. The next thing that's connected to that frame member is going to be my handle. Okay. My handle has a connection at the joint to the frame, and then a connection to our next link. We're going to call that connecting rod to our slider. So we're going to draw this so it goes up. This is going to be the other joint. And then our point of interest is going to come out, and then it's going to be connected back. And then we're going to call this point X. Now I'm again just sketching, so try to be as straight as possible. So this is our handle. Then we're going to draw that connecting rod. That connecting rod is going to kind of go down, and it is going to connect to, we're going to connect it to the center of our slider. Okay. Our slider is going to be a rectangle, and it is going to be constrained vertically. So we need to draw a vertical line and represent it as a frame member on the left-hand side so that we can see that it's constrained going vertical. Whether you put this on the left or on the right really doesn't matter. I try to emulate which side the constraint is on, and in this case it is on the left-hand side. So, but it might sometimes be on both sides, but you only have to show it on one side. Now, each one of the filled in circles that I have, okay, so this is always a joint, okay? It's not just an endpoint, it's a joint where we're going to have two items come together and have relative motion, okay? This is always the frame, okay? Always. That's how we're going to show it. And then simple links and such are pretty straightforward. Now, in addition to showing the elements in their standard way, we also need to number and letter items on our kinematic diagram. So the first thing is we're going to number the individual links. The first link that we are going to number is going to be our frame. Even though a lot of times you don't think of a frame as being a link, you think of a link as moving, but part of a mechanism, we do have to have that fixed or that frame. So our frame is going to always be number one, and we're going to put a circle around it. Even if the frame is separate pieces, it is only considered once as number one. Okay. So in the case of this mechanism, I have a frame member on the left and on the right. Okay. But it's only considered one time as the frame, even if there's multiple pieces that it comes from. Does that make sense? It will, as we do more and more. So that's going to be number one. Number two, then, number three and number four are then going to be the other links that are moving. So I like to go in order, kind of going from my frame to what's connected to the frame. Number two, or my handle, is going to be connected to the frame. I would call my connecting rod, because it's going from the handle then to the blade in this case, or the slider. And number four would be my slider. It's kind of like the output. I think of my frame as my in, my handle, and then the motion is going through and down to my slider. Now, in the case that they created their kinematic diagram, they had number one as the frame, which is always the frame. They had number two as the handle, but then they had number three as the slider, and number four is going to be the connecting rod. Again, it actually doesn't matter so much on those numbers, because it just means that have to make sure that you're consistent. When we get into calculating velocities and accelerations, these numbers and letters are they're going to mean something. Okay. So, as long as you're consistent, you have it labeled correctly, and what you're calculating down below corresponds. The orders of the 2, 3s, and the 4s isn't as critical, but you're going to notice I tend to go from input to output with my numbers. Okay. Now the letters that are there, the letters are going to be on the joints. So again, starting where our frame is, our first joint is going to be A at the frame. Going to our next one, I'm going to be calling my number 2 link is going to be B. C is going to be at the connection between the slider and the connecting rod. And then we always have a D with a slider, because that's going to be the constraint that we have with the direction of the linear motion. Okay. So in this case, we have 4 linkages in our mechanism, and we have 4 joints in our mechanism. Okay, the joints are letters, the links are going to be the numbers. All right. Okay, so any questions about example 1.1? Yes, Chris. Oh, you don't. I'm sorry. Okay, I thought you put your hand up. Okay. All right. So now what we're going to do is we're going to look at the next problem. The next problem is 1.2. Now, because you're going to be submitting this, you can submit this as a photograph in the practice problems, or if you want to take a scan of it and you want to put it into a document, you can do that as well. Okay. But going forward after this one, this is the only hand-drawn one that you're going to do for our practice problems. We are now going to be shifting gears, and we are going to be creating the kinematic diagram for this vice scripts, but we're going to be doing it in AutoCAD. Okay. So what I'm going to have you do right now is open up AutoCAD. All right. And we're going to create a start file, a kinematic start file with the appropriate layers, as well as some of the elements that were just, created, so that you're not always reinventing each time that you start. So I am going to go ahead and I'm going to open up AutoCAD. And when you get started on a new file, we're going to click on the ACAD template, kind of just that standard English template. So I'm going to go into, once you get it open, you're going to go to File, New. I'll kind of do this slowly because I'm not sure where everybody's at. And then the template that's going to come up is going to be, you want to click on ACAD, just the regular ACAD generic one. Okay. Once we get into there, you're going to notice that if we go up to your layers, the only layer that's identified here is the 0 layer. We don't draw on the 0 layer, so we need to create a couple layers here. I'm going to go into layer properties. Now, we're not going to worry about cutting plane line and hitting lines and all that kind of stuff, because remember, we aren't making these drawings for the purpose of sending them out to the production floor for the parts to be made. And we're not going to be adding dimensions and tolerances. This is layout work. Okay. So we're just going to add a couple layers so that we do have that ability to kind of put things on the appropriate layer, but it's not going to be as extensive as we did in our drawing classes or our tech drafting classes. So I'm going to click on 0 layer and I'm going to hit enter. And the first one that I'm going to do is I'm going to do object lines, right? So object line is just going to be our standard continuous line. So it's going to be white. The line type is going to be continuous. And I want to change the line weight. So you're going to click on line weight here from default. I'm going to put it on 0.5 millimeters. And I'm going to hit OK. So you're going to notice that that gets thicker. Then I'm going to reselect. I'm going to hit enter. And the next one that we're going to do is going to be hatch. And I'm going to change that color. I always like yellow. You really can choose whatever colors you want, but make sure that whatever the type of background that you have, it easily shows up. So for instance, if you have a black background, you're going to be doing screenshots for me. If you do dark blue, it's going to be hard for me to see. And I'm going to say, I can't see it. All right. So make sure you're using things like yellow and white and magenta and cyan. Those are going to be the ones that are going to be easily read if you have a dark background, or other colors if you're using a white background. Okay. So just make sure that it's easily seen. And then the next one that we want to do is going to be notes. Okay. Again, notes, dimensions, anything that we add in that sense are going to be on that layer. And I'm going to make those magenta. Okay. Oh, and the line weight for both hatch and for note goes back to default. It's going to copy from that previous layer. So click that back up to default. Okay. And once you have those in place, you can just hit the X and then you should be able to arrow down on your layers and those 3 layers should show up. I'm going to go to the object line layer right away. Okay. Now, the next thing I'm going to show you is when we create our lines, because we changed the line weight, for instance, on the object line, it's nice to be able to see those differences. If you want to turn the line weight on so that you can show the line weight, if you had me in the past, I kind of showed you how to do that. But if you haven't, or it's been a while, you're going to go down to the 3 customization lines in the bottom right-hand corner of the screen. And you're going to click on line weight. And what's going to happen, it's going to populate a little icon down at the bottom here. And it's going to say show hide line weight. If you click on that, it's going to activate. Christian. They're all continuous. And I've got hatch, notes, and object line. White for object, magenta for notes, and yellow for hatch. They're all continuous line types, but then the only line weight that's different is object, and it's going to be 0.5 millimeters. Got it? Anybody else? Okay. So I'll close that out. So yeah, and then make sure you're on the object line. And then I like to turn on the line weights because I can see my object lines get I don't know, heavier, and they're easier to see. So now what we're going to do is we're going to draw a couple of these elements so that, again, we're going to be starting a kinematic start file. So we're going to start by drawing a frame member because every kinematic drawing that you're going to do is going to have a frame. So to do that, we are going to draw a circle, okay? And I'm on my object line, or on my object layer. I'm just going to start in the middle here. And you're going to notice that this is in radius mode. So what I want to do is I want to create this so that it's about a 1/2 inch across. Okay. So that means my radius is going to be 0.25. Okay. So I'm going to zoom in a 0.25 radius circle or a 1/2 inch diameter circle. And then I'm going to do the line command. I'm going to click on one of the quadrants and I'm going to go straight down. Make sure if you need to put ortho on so it goes straight down, and go straight down about 0.375, 3/8 of an inch. Okay. And I'm going to hit escape and I'm going to do another line that is going to go from the quadrant and go down 0.375. Okay. A 1/4 of an inch. So the radius of the circle is a 1/4 of an inch. The diameter would be a 1/2 inch, depending on which one you choose. And then 3/8 of an inch going straight down from the quadrant. Then what I'm going to do is I'm going to add a rectangle, okay, to the bottom here. Oh, no, I'm going to do a line. I'm going to do a line. So I'm going to extend a line from the edge. So I'm going to activate the edge, go straight out so that it's in line with the bottom. So again, I'm going to hover over my endpoint of my line, and I'm not going to click, but I'm going to go to the left. And I just want to go out a little bit of a distance to extend beyond, and I'm going to click, and then I'm going to go across, and then I'm going to click on the other side. And this is just going to be, if you would, the bottom of the frame. So if I look back at, actually, I'm going to look at my illustration. I'm just drawing this line across the bottom. I did the 1/2 circle here, the 2 lines going down, and now I just went across the bottom. That's just what that line is going to be. Okay. Now I'm going to get rid of, I'm going to trim away the inside of that circle. So you just left click and drag across, hit escape to get done with that command. Okay. And then the next thing I'm going to do is I am going to create a rectangle, and the rectangle is going to be what I'm going to hatch within, and then I'm going to get rid of it. So I'm going to use it for construction purposes on the end of this rectangle or that line. And then I'm going to go straight down about this far. Okay. It doesn't have to be, you know, perfect, but about that far. Now I'm going to change my layer to hatch. And I'm going to hatch inside of that rectangle, okay? Because what I want to do is I want to show these hatch lines down below. That's going to be like my anchoring of my frame, if you would, like it's not going to move. Okay. So to do that, I go on the hatch layer, and then the hatch command is in the draw section on the left-hand side. So I'm going to click on that. And all I'm going to do is I'm going to go and I'm going to hover inside of my rectangle. And if my rectangle is closed properly, you're going to see this preview. And I want the ANSI 31 hatch highlighted up here if you need to. All right. Now the distance I think is good for the size that we have. So that is scaled at 1. But if you wanted to make it closer or further apart, you can change that scale. I'm going to leave mine in there. So I'm just simply going to left click inside of there. And then I'm going to click OK. All right. The hatch command is in the draw section right here. You see it? Right there. Okay. So once you have your hatch in there, now you can get rid of that rectangle. So I'm simply going to hit the erase. I'm going to click on the rectangle, and then I'm going to hit enter. And because all I want left there, I just needed the rectangle for where I was going to hatch within. Okay. Now is a good time to do a save. So I'm going to do a file, save as, and I'm just going to call this, I'm going to navigate to where I want it to go. So if you have a flash drive or on your OneDrive, I am going to go to my OneDrive, mechanical design, kinematics, and I'm going to call this kinematic start. Okay, that's it, kinematic start. And that way, when you start an assignment, because you're going to be doing all of your drawings in AutoCAD, now you're going to have this available to you. And we're going to keep adding to it, but this is our first save. Now, the next thing we want to do is we want to add the circle on the inside here, which is going to be on the center of that half circle. We are going to create the joint. So I'm going to start off by going back to my object line. I'm going to put a circle at the center here, and that is going to have a radius of 0.0625. Okay, so about that big. So radius of 1/16 of an inch or a diameter of 1/8 of an inch. We're going to change our hatch or change our layer back to hatch. And then we're going to hatch. So right above the draw in the draw menu here, just to the right of the line command, hatch. I'm going to go on the inside of my circle, but I don't want it to be these lines. I want it to be filled in solid. So I'm going to click on solid, and now I'm going to go down and I'm going to fill that in with a solid hatch. So you can left click in there and hit OK. So it has to be filled in. You can't just have a circle. A joint is always going to be a filled in or a solid circle to show that pin joint. Okay. So now I have my frame member created. I'm done. Okay. So the next thing that I want to add is going to be a slider. When we do a simple link, it's just connecting, lines. It's just a straight line. So we're not going to draw anything for that. But let's draw a slider this time. So we are going to do a rectangle. Whoops, let me change my layer back to the object line layer. I'm going to do a simple rectangle. I'm going to make mine horizontal, and I'm going to make it about that big. So about 3/4 of an inch by 3/8 of an inch. Okay, something like that, something close to that. Now what I'm going to do is I'm going to find the center by drawing 2 diagonal lines across. And at the intersection of those diagonal lines, I am now going to put my circle for the joint. Now, instead of going back through and drawing the circle and filling in the hatch, I'm simply going to copy my circle with the hatch from over here to the intersection that I just created of my diagonal lines. So I'm going to go up to the copy command in the modify section on my ribbon. I'm going to left click, don't drag, and left click to select those 2 items, hit enter, and my displacement is going to go from the center of that circle to the intersection, the intersection of my two lines. Now I'm going to turn off my ortho. I have ortho still on, and I'm going to shift right mouse button, and I'm going to get to the intersection. So it just highlights on that. Okay. Once I have it at the very center of my rectangle, I can go ahead and erase the two diagonal lines. Okay. Now I also need to create that hatching, but in a longer format for my slider. So in this case, I'm going to start a rectangle. I'm going to activate the corner, make sure my rectangle is in line with this. And I'm going to go over, and it doesn't have to be quite as wide, something like right about like that. Now I'm going to change my layer to the hatch layer. I'm going to go back to the hatch command, switch it to the ANSI 31, and then go inside and left click. And then okay. And then I'm going to trim away the parts of the rectangle that I don't want. So I don't want that part, or that line, but I want the horizontal line so I can see the extents of that surface. Okay. All right. Now's a good time to do another save on the Kinematics start. Okay. So now you have a frame drawn, you have a slider drawn. Now what we want to do is we want to put some of those labels in place, okay, so that they're there for you, and all you have to do is then move them to the right position once you create your diagram. So to do that, I'm going to change my layer to the notes layer, and I am going to add a multi-line text. So I'm going to arrow down, I'm going to do multi-line text. And I'm going to create up here just a rectangle about that long, okay? And I'm going to start by putting the number 1 in position, okay? And then I'm going to hit, not enter, left click outside of it. Now what I'm going to do is, as we look at the number here, I'm going to also put, actually I'm going to move it first. So you don't have to move it if you don't want to, but I want to kind of move it so that when I look at the number compared to my frame, is it appropriate size? I don't want it too big and I don't want it too little. All right. The way that I have it here right now, it seems like it's a good size. I don't know yours. If you followed along with the same size as I've been making mine, it should be close to what I have here. Okay. So I like this size. So I'm simply going to move this back up. Okay. And what I'm going to do is we're going to do number 1, 2, 3, and 4. Okay. And we're going to put circles around each one. So I'm going to stay on my notes line. I'm going to draw a circle around my number. So I'm going to go in about the center here, and I'm just going to draw a circle. So that's about that big. Again, this doesn't have to be, an accurate size for the circle around here. We just want it to be around that number. Now what I'm going to do is I'm going to copy the circle and the number, and I'm going to copy it from the base position, and I'm going to put my ortho back on. This is going to be for 2, 3, and 4. Okay. I'm going to double click on the second one, and I'm going to backspace, and I'm going to call that number 2. And left click on the outside to deselect. Left click on the 1, change it to 3, and then left click on the outside to deselect. And then left click backspace 4. And we have now 1, 2, 3, and 4 for each one of our link designations. Okay. We now need to add letters A, B, C, and D, right? Now, sometimes there might be more, and then you can just add them, but most often we're going to be dealing with 4-bar mechanisms. So I'm going to just copy. You can use the copy command up here. I always want to do my keyboard. And I'm going to copy 1, 2, 3, and 4, not the circles, because when we identify the letters for the joints, there's not circles around them, only around the numbers. I'm going to hit enter and my base position is going to be up and I'm just going to pull these down outside of the circles. And now, so that they're the same size as the numbers, I'm going to double click, for instance, on number 1, and that's going to be A. It has to be capital A. See, capital A. Left click to deselect. Then I'm going to have B. Double click C and double click D. Chris, do you have a question?
Yeah, just split them up. Did you there was a way for the text to be like distract center?
No, I did them as 2 separate entities. Yeah, you could do a balloon and play around with the size, but to me, that's just, again, it's not going to render any results where we're going to be creating this for documentation for this to be made. This is layout work, but we need to identify, because when we start calculating velocities and accelerations, we have to know what joints and points and links that we're actually identifying. So we're just practicing getting these down. So yeah. Okay, so now I've got my joint designations. I've got my my link designations. I want to add 2 more letters, and that's going to be an X and a Y for any special points of interest that we might want to add. That way we don't have to do it later on. So I'm just going to copy 2 of the letters. And I'm just going to bring those down. Okay. And they're just, again, going to be just available for us to move where we want them to go. And this is going to be an X and a Y. And then the other one that we're gonna, do we want to do it? The other one we're gonna add is I am going to copy one more time a single joint so that it's by itself and I can copy it over when I need it as well. So I'm gonna copy a joint. So we're just gonna do the circle with the yellow center, enter, and I'm going to go from that base position and I'm just going to add one on the outside. That way I have a single joint that I can copy and put wherever I want it to go. Okay. Now I'm going to do one more save on my kinematic start file. So now for every assignment that you pull up, you're going to pull up the kinematic start file. And you are going to then rename it right away, assignment 1A, assignment 1B, whatever it might be, assignment 2, assignment 3. And then this way you're not having to do that work that we just did with layers and the frame and the slider and all that kind of stuff. Additionally, if you want to, you can do all of your kinematic diagrams. If they're the same units of measure and it makes sense size-wise, you can do them all in a single file and just do your screenshots around the areas that are going to be for each one of the problems that we assign. Okay, so that's another strategy. So now you have your kinematic start file, and then we can use this to use AutoCAD to draw a kinematic diagram. So we've been talking for, well, I guess it's about an hour. You guys, should we keep going and go into the thing, or do you guys need a break? Oh, okay. Yeah, I can show you how to do that. So if you need to change any of these, you're going to double click and it's going to put in this, it's going to activate the text editing box. And then you just do a backspace and then you can change it to whatever number you want. And then you're going to left click outside to deactivate it. Okay, well then why don't we take a little bit of a break? I know somebody said they would like a little bit of a break, and then I can address any individual questions that you have about this file in the room here. Virtually, are you guys doing okay? Hopefully. All right. So I'll stop the recording right now and we'll take a little bit of a break. So 15 minutes. So at 7:30, we'll resume.